So before I start, I just kind of want to put into context, everything that's changed or kind of happened in the last year since the last time we all met in this room. So one of the things that's going to be really evident, as you walk around the hall, all the different halls at NAB, is that IP as a technology now has really come of age. 2018 really is the year of IP. And in fact, if you're looking for a next generation infrastructure, your first consideration today is probably going to be IP above any other type of interface choice. Part of that is being driven by the availability and adoption now of industry standards, including standards like SMPTE ST2110. So at Evertz, we've been deploying at scale full IP infrastructures, full IP systems since 2014. And to date, we have over 100 plus deployments kind of distributed around the world. We have more large-scale IP systems deployed, I think, probably than almost everyone else put together. So over that time, we've got a lot of feedback from our customers, our user base, and they've learned a lot in how to get the best leverage out of these new IP infrastructures. And one of the things that some of these IP early adopters have discovered is you can do things differently and you can do things better with IP. And in fact, you really shouldn't just use IP as a means to duplicate what you're doing already in SDI. You're really doing yourself almost a disservice for doing that. IP infrastructures really have greater agility, flexibility, versatility, and they really let you have better, more efficient, faster workflows. So again, 2018 is really the year of IP, and what I want to talk about with you over the next 45 minutes or so is all of the new technologies that we're going to be introducing and showing you at NAB that really leverage all of these IP advantages. So I won't read through this list, but here's kind of a bit of an agenda of all the things that I want to talk about with you today. So the first thing is, historically, Evertz has always been, very actively involved in standards work. If you spend any time walking around the halls at NAB this year, you will see us, participating in interoperability events here at NAB. We also do off-site ones. We belong to industry consortiums like AIMS, and one of our objectives really is to educate the industry and to show and provide solutions for users who are trying to transition from SDI to IP. So part of that work is promoting the adoption of industry standards, including SMPTE ST2110, as well as industry specifications like AMWA ISO 4 for registration and discovery and AMWA ISO 5 for network connectivity. So I encourage you to stop by the Evertz booth, North Hall 1503. We're going to be doing some really interesting things. Some of that is going to be some interoperability demonstrations, which are including demonstrations for SMPTE ST2110, AMWA ISO 4 and ISO 5 with some of our industry partners like Ross Video, Sony Tektronix, Cisco, VizRT, and Wohler. So again, if you get a chance, stop by the booth and check out some of these demos. They're very interesting. In addition, I encourage you to go to visit the IP showcase. So you've probably heard of this. Evertz, along with I think over 60 of our industry partners now, we're going to be demonstrating sort of industry-wide interoperability with technologies such as SMPTE ST2110, AMWA ISO 4, AMWA ISO 5. The IP showcase is kind of divided up into different areas, sort of different areas of focus for different technologies and different applications. So we have demonstrations in all of these different areas. So again, if you get a chance, go visit the IP showcase. I think you'll find that also very interesting. So I have previously mentioned, that we are heavily involved in standards work, including SMPTE ST2110. So our SDVN, or Software-Defined Video Networking Solutions, do include support for SMPTE ST2110. Now, Now this is sort of a diagram of all of the different Evertz software-defined video networking. This is a solution view with all of the different sort of network resources that we can provide. The heart of our technology is, it's kind of hard to see at the top there, something that we call orchestration, control, and management. So we have all of these resources, and they're essentially managed, by our orchestration and control platform called Magnum. Now what orchestration and control does, actually it does a lot of things. First of all, it provides a single point of unified control for your infrastructure. It also gives you the ability to manage, all of the resources in your facility or in your infrastructure. So this includes things like bandwidth management, making sure you don't have oversubscription of your network switch. It also provides a very familiar, consistent, and that's the key word, interface. So, if your facility is a mix of IP, maybe some SDI, maybe a mix of both, it provides a single sort of unified look and feel to make things sort of simpler and easier to understand for your operators. Orchestration control also provides the ability to schedule resources in your facilities. So really, Magnum, our orchestration and control system, is essentially the brains and the heart of your infrastructure. Now, in addition to that, though, we do offer some other tools to supplement and to augment what our orchestration platform does. And these include analytics, some enhanced control functions, as well as monitoring tools. And I'm going to talk a little bit about these over the next few slides. So the first thing that I really want to focus on is View. We call this our Intelligent Operations and Control Platform. And essentially what View does is View is a platform for really designed to create very tailored, customized, and streamlined operational workflows. And the way it does that is through the ability to create very, very efficient user interfaces. So this is kind of an example of what you would see on a View workstation. You would have access through your orchestration system to all of the different controls and functions for every device on your network. But if you're just trying to do, a very simple sort of workflow task or a complex workflow task, you may not need to have access to every single control parameter for every single device on your network. That gets pretty complicated. So essentially what View does is it lets you sort of pick and choose all of the different controls from all of the different resources, in your infrastructure, and pull them all into a single integrated control interface. So, if you have a particular sort of task that you're trying to do, you just pull on those interfaces, you just pull all of those different control functions, only the ones you need, not the ones you don't, and you can create a very simple, very efficient user interface that only has the controls that you need and none of the ones that you don't, making life easier for your operators. Now, but it's a lot more than that. So, View is very versatile. Like View spans different applications. So you can use View in a live production application, playout, distribution, pretty much any application that you think of. And it gives you the ability to also very rapidly reconfigure your interfaces to sort of basically with a one button push to reconfigure your interface for the next application. So it's also very fast. You have operators that have to be exposed to a lot of different systems. Orchestration systems, network monitoring, playout, your live production systems. These could be spanned over multiple screens. You might have hardware-based panels, different keyboards, different mice. It's a lot of stuff. It can be overwhelming for an operator to have to look at all of these different interfaces, and you really only might need to use one or two or three sort of functions from each of these interfaces. So essentially what View does is that it unifies all of these different systems onto a single interface. You just pull all of the different particular controls and functions that you need from all of these sort of different disparate systems onto a single user interface. And everything he needs is there, but nothing he doesn't isn't. View is also extensible. One of the things that you see in a lot of control systems in our industry is really a big focus on sort of video and audio type controls. View kind of expands on that. And essentially View gives you the ability to control sort of arguably what are sort of non-video and non-audio type function, not those core functions, but things like, as removed as things like room controllers. So you could have View control a room controller where you could bring up the lights in your studio, or you could control a camera. One of the things that we're going to be showing new at NAB this year also is that View now also supports third-party devices through third-party widgets. So we have devices from that we're supporting from like Tektronix, Wohler, where you can just pull different control parameters from those third-party products and actually incorporate them into your user interface. Now, View is a mixture of hardware control panels, software platforms, as well as it's an embedded technology in some of our products, like our RF products, our live production products have embedded View interfaces. So one of the new things that we're going to be showing at NAB this year is what we call the View Touch 10, and this is a standalone View interface. So, it's a little 10-inch touchscreen. You can take this, you can plug this in anywhere you need a control interface, and directly from the panel, you don't have to do it from a back-end system, you can actually configure a custom user interface right from the monitor. So it's a very small, compact, but very flexible control solution for creating those custom user interfaces. Now, switch gears here a bit. Next thing I want to talk about is Insight. And this is our big data analytics platform. First of all, what is big data and why is it important? Big data is essentially, if you think of a typical broadcast infrastructure, it's creating and generating all sorts of different types of system data. And typically, as an industry, we don't really use a lot of that data. It just gets basically ignored. But if big data analytics is the concept of essentially aggregating and collecting all of this data, analyzing it, looking for patterns of behavior, and from there, to see if there's opportunities for creating new efficiencies and better ways of doing things. It can also be a very, very powerful troubleshooting tool. So you can kind of see here, all the different arrows represent sort of all the different types of data that's created by a typical facility. And typically, most facilities today are probably only looking at a handful of these different types of data. But Insight, our big data analytics platform, basically aggregates all of this data, aggregates it, collects it, analyzes it, using machine learning prediction and some other analytical tools. It's looking for trends in behavior. And then from there, it presents that information to the user in the form of visualizations or user reports. So this can be a very, very sort of predictive and very powerful troubleshooting tool. Just kind of a screenshot here of how, for in this particular case, how we're looking at sort of some bandwidth considerations going through a network switch of the type of dashboards that an operator would see. Now, new for NAB is version 10 of Insight. Lots and lots of new features, lots of emphasis, new emphasis on security. So between all of the different Insight nodes now, we offer secure connections. We have built-in more system resiliency, and probably the most important thing now is we offer what we call sort of baseline packages. So some of the feedback we've had from users is that Insight is an incredibly powerful tool, but we'd like to see some sort of pre-canned dashboards on the type of data that we should collect. So rather now than having the user have to develop that first set of dashboards, we actually do it for them now. VistaLink Pro, our network management system, we're showing some new features for NAB. This is called your IPST flow visualization. So essentially, one of the things that we've had to do, as we transition to IP, is develop new diagnostic tools for operators. Some of the ways, conceptually, that we think of a baseband SDI infrastructure don't necessarily apply to IP, right? I mean, you can have multiple signals now going through an Ethernet connection going in both directions. So it can be more challenging to try to figure out just visually sort of how signals are flowing. So we've created new tools. In this case, the IPST, which essentially allows you to trace all the IP flows through your network. Now, next thing I want to talk about, a very, very interesting new technology. This is called virtual media infrastructure. So typically, if you think, we're going to come back to this chart here. If you think of a typical infrastructure, it's typically made up of what we called discrete resources. So these are things on your network. Let's say in this case, like a multi-viewer. It's essentially a fixed function device. It's always a multi-viewer, never changes. That's just what it is. So that's kind of what we call a pool of discrete resources. But now, with this transition to IP, this has really leveraged the creation of a new type of network resource that we call a virtualized resource. Now, Insight, our virtual media processing platform. This is our virtualization platform, and how I'm going to define virtualization for our discussion today is it's the separation or decoupling of services and processing functions from hardware. So going back to that multi-viewer example, it's a piece of hardware, it did a certain thing, and they were permanently locked together. But with virtualization, we take that hardware and what that hardware does, and we can pull them apart. Great analogy. Think of a calculator versus a smartphone running a calculator application. That calculator, always a calculator, never going to change. Smartphone is defined by the types of applications you run on it. So you run a calculator app, calculator. You run a music player app, it's a music player. We can separate the function from the underlying smartphone hardware. So that's the same analogy that we could use for our EVEdge virtualization platform. So why would you want to do that? It makes your virtualization, or EVEdge, your virtualization platform, becomes hardware agnostic. You're not defined by a single hardware type. Now, you can have virtualization running on different types of hardware platforms, which I'm going to get into. It also becomes an IP replacement for glue. So now that we can do things, process things totally natively IP, we don't have to translate things back to baseband SDI and then re-encode them. So we can use less hardware, it's technically less complicated. Because we can have more choices now with processing hardware, it can be potentially easier to scale up. So as you need to increase processing capability, you have more options now. And again, because we've separated functions from hardware, you can keep a pool of software licenses for different functions at hand, and then you can deploy them sort of when and where you need them based on your particular application. So it's very, very flexible. Also, that hardware can be constantly repurposed for new functions as industry requirements change and as we introduce new sort of processing functions. Sorry, so this is a sort of a deconstructed view of what EVEdge looks like. So you look at the bottom layer, that represents the physical layer. So I mentioned EVEdge is sort of hardware agnostic. It can run on different types of hardware. It can run like on an Intel x86 sort of COTS server. It can run like in a virtual machine environment. And for certain types of applications where you need a lot of processing capability or really low latency, we also offer our own FPGA accelerated processing cards. On top of those, you can provision different types of processing functions. So in this case, it's everything from things like up-down cross-conversion, key fill. We have different types of IP gateways and video and audio processing. And all that's managed through our virtual service coordination layer, which essentially manages the what, where, and when sort of virtual services can be deployed. And then on top of that is our control system, which I talked about earlier, our orchestration control system, Magnum, and then on top of that, View. So you can create custom user interfaces for every time that for your EVEdge platform. So it's a very, very flexible sort of architecture. One of the things that we're going to be showing that's going to be brand new at NAB this year is our EV Blade Z10 AP 10G. This is our small form factor FPGA accelerated compute blade. So we have a larger version of this, but this is our sort of the compact version, really targeted sort of at things like trucks or in applications where you might only need a little bit of virtualization resources. So on this card, right, you can provision this with different types of functions. So this can become whatever you need it to be. It also has an audio processor that's embedded onto it for doing applications like Dolby encoding and decoding. So again, it's a very, very flexible, compact, small platform. Now, the next thing I want to talk about is some of our cloud-based or file-based solutions. These are our solutions, file-based, for both linear and non-linear delivery. So this includes Mediator X. This is our media asset management platform, manages all of the workflow functions for both linear and non-linear playout. Our integrated playout engine, Overture RT Live, as well as RenderX, our transform and conform engine. These file-based solutions, they can run in a public cloud, like an Amazon Web Service type of deployment. They can run in a private data center or even run on on-premise hardware. Now, one of the things that we're really excited about, we're going to be showing at NAB this year, is some third-party integration for our cloud-based solutions. So this thing, and I think in that link that or in that card I gave you, there's actually a link to a press release that we did to show some of the third-party integration demonstrations that we're going to be showing with Intera Systems, Avid, Cloudian, Hyperstore. We also are going to be showing a social media integration operation with iPowwow. We're going to have a UHD and HDR playout, as well as an Amazon Web Service Live demonstration. Now, I mentioned at the very beginning of my presentation that we've been deploying systems in the field since IP systems since 2014. I think this is going on our 5th year now. So at the time, our initial systems were using 10 gigabit Ethernet interfaces. Now, 5 years is a long time in our industry. Industry requirements are starting to evolve to the point now, because we have to address new requirements for things like ultra high definition, which ideally, if you're running an uncompressed infrastructure, you need something bigger than 10 gig. So we do have, we're going to be showing on the booth our range of 25 and 10 gigabit infrastructure solutions. So everything from gateways, network switches, big network switches, small network switches, as well as some 25 gig line cards for some of our existing network switches. Now, the next thing I want to talk about, it's going to be one of the big highlights of our booth this NAB, is some of our transport applications. So for every media organization is going to has that requirement to move media between different facilities. And typically there are different ways of doing that. So what we're going to be launching at NAB, this is our new Scorpion Smart Media Aggregation platform. Essentially what this platform is, it is a transport platform for moving, let's say, content around between different nodes in your organization, and it really uses dark fiber as well as managed IP connections. So it can do both. Typically, these type of transport applications have been done using only dark fiber connections, but we're starting to see a bit of a shift where there's a lot more interest now in also doing it over managed IP connections. Now, I mentioned this is a transport application. So the type of things that we're transporting, obviously, are all the different types of signals that you might have in a modern facility. And that's actually a fairly extensive range of different types of signals. So different types of, all the different flavors of SDI, serial data, HDMI, you have AES audio, analog audio, you have some analog video still. So that's a lot of different types of signals. So we've built that functionality into the Scorpion platform. And there's 3 flavors of the Scorpion platform. So the first is the Scorpion X18. This is really targeted at large-scale transport applications. It has a lot of, it has an extensive collection of different dark fiber interfaces so that you can connect it to the largest of dark fiber networks. It also has user-selectable mini modules so that you can essentially custom tailor this with just the different types of signal interfaces that you need for your own particular facility. Has a built-in 12 gig router on it for routing all the signals inside of the device. And again, this is designed to transport over IP networks as well as dark fiber. So it also does support SMPTE's newest IP uncompressed standard, SMPTE ST2110. Now, we also have another brand new Scorpion platform. This is called the Scorpion 4. It has sort of that same core feature set that you see in the Scorpion X18, but this is really targeted at sort of smaller applications. What we would call sort of under workbench or under desk type applications, maybe a throwdown application. So rather than supporting 18 different user selectable mini modules, this supports 4. One of the other big features of this is that it has no fans. Has no fans built into it, so it's completely silent. So this is finding a lot of homes in places like audio control rooms, studios, edit suites, anywhere where you need some kind of transport or encapsulation, but you can't really tolerate any noise. We also have another brand new version of Scorpion called the Scorpion 2. This is a very, very tiny, small form factor version of Scorpion. Again, designed for what we call throwdown applications, and like the Scorpion 4, has no fans, it's only passively cooled. Again, great for anywhere that you can't tolerate a lot of noise. Scorpion 18, really targeted at different applications, including venues, large venues. Rental houses seem to be really interested in it, really interested in this. We're finding a lot of homes, as well as trucks and OB vans. The Scorpion 2 and the Scorpion 4, also finding applications in venues. Actually, Scorpion 2 is great for camera feed. So if you have a camera in like an arena, but it's kind of located at a very far end of the arena, you can plug the camera in, the SDI into the SDI output of your camera into the Scorpion 2 and take a fiber feed back. So it's great for that type of throwdown application. Also, again, finding homes in rental houses. Scorpion 4, very similarly, finding homes in trucks. And where we're seeing a lot of uses for this are in those environments where you can't tolerate a lot of noise, like those post-production suites and those edit suites. So next thing I want to talk about is what we call our video delivery infrastructure, or some of our compression solutions. So one of the things that we've seen from some of our customers, mostly our customers that onboard and distribute a lot of content, like for OTT applications, is that they're really challenged sometimes in that, as they onboard a lot of content, that content tends to be from all sorts of different providers, comes in different formats. And technically, it can be very challenging when they're onboarding this content to efficiently onboard it, because every one of these transport streams that they're getting in is formatted slightly differently. And this has necessitated them having sort of multiple hardware setups to onboard all of these different types of transport streams. So it's very technically complex, takes up a lot of space, and it can be actually fairly costly because you're duplicating a lot of equipment, and it's hard for operators to essentially to control all of these different systems. So we came up with a new solution called MediaFlow. And essentially what this is, we call this our Agile Transport Stream Manipulation System. And this simplifies that entire application, that entire sort of extended workflow. First thing it does is it processes everything natively in the IP domain. So in older systems that are processing transport streams, typically sometimes they're decoding to SDI, doing all this processing, then re-encoding. With MediaFlow, we do everything in the IP domain, so that greatly simplifies your workflow and minimizes the amount of hardware that you need. In addition, we've embedded a lot of different types of processing functions that typically would have been done with sort of outboard systems into this MediaFlow systems. So that includes everything like from captioning insertion, SCSI 35 insertion, signal delays, we can do lip sync, up-down cross conversions. So all of these functions that typically would have been done with sort of third-party or outboard systems, all fully embedded within this MediaFlow system, which is doing also, again, everything natively in the IP domain. At the very beginning of my slide, I talked about, with the IP, an opportunity to do things better. So this is a great example. We're going to be showing something really new, really exciting at NAB this year, cloud-based closed captioning. So if you look at a typical captioning infrastructure today, captioning uses a lot of sort of really old infrastructure. Things like modems are still used in this greater sort of captioning infrastructure. So with this transition to IP, this is a great opportunity for us to essentially kind of reinvent how captioning is done. So we're bringing that into the age of IP. And replacing this aging infrastructure with an IP infrastructure. We're also going to have captioners, their means of embedding, of interfacing into the captioning system is going to be now done through very simple sort of web browser-based type interfaces. We're also offering new ways of deploying your captioning infrastructure. So we call this Caption Conductor. This is our IP-based captioning solution. So I won't get too far into this, but this is an example of how you would do it sort of on-premise, where you have your access server, which is how the captioners actually interface in the system, and your facility server, which is basically what's produced or what's essentially managing the creation of all those captioning data and sending that to your caption encoders. So this typically, on the left side of there, would have been done over things like using telephone modems. So we've moved this all into the age of, IP. This is all done over IP now, using a very simple web browser for the captioners to interface into the system. We've taken this to the next level. One of the things that Evertz has been doing is, we've been deploying cloud-based. We're the leaders in cloud-based technology. So you've probably seen some of our press releases on the Discovery Network and how they're doing cloud-based playout. We've taken that knowledge that we've learned from having to learn how to do things in a cloud, and we've extended this into the captioning realm. So now, we can do a full captioning-based system in the cloud, using public data centers such as Amazon Web Service. So you can move your entire captioning infrastructure out of your premise into the cloud. The ability, advantage of doing this, obviously, you don't have that capital expenditure of having to create your own captioning infrastructure. It also gives you the ability to rapidly scale up or scale down your captioning capacity, based on what your immediate sort of captioning requirements are. So it's a very, very flexible way of doing it. Now, next thing I want to talk about is timing. So again, I mentioned, one of the big things, is this industry adoption today of SMPTE ST2110. One of the big technologies that's embedded within SMPTE 2110 is SMPTE ST29, Precision Time Protocol. This is the next generation timing technology baked into ST2110. And this is a great opportunity for us to leverage this IP-based timing technology to replace our existing legacy-based timing technologies like color blackburst, which have actually been around for a long time. So we're going to be showing at NAB this year some of our new IP-based timing technologies, which support SMPTE ST2059. This includes 5700 MSC. This is an IP network Grandmaster clock and sync pulse generator. So this provides all of the functionality of a typical baseband sync pulse generator. And on top of that, we also offer all of the IP timing technologies that are part of SMPTE ST2110. So that includes SMPTE ST2059, also IEEE 1588, and network time protocol and other IP-based timing technologies. And on top of that, this platform also supports all of the legacy timing signals that you would currently need in a baseband facility. So this has all of the timing signals that you would need for an IP-based facility, for an existing baseband facility, or for a hybrid of the two. For all of the, now typically what you see in legacy sync pulse generators is you have to have some redundancy built into it. So also a brand new product we're going to be showing at NAB this year, 5700 MSE auto changeover, and this is for switching between a backup and between your primary and your backup 5700 MSCs to provide you that next level of redundancy that you may need for all your baseband signals. Another new product, if you had a full SMPTE ST2059 infrastructure built into your facility, you may probably still, for the time being, have some islands within your facility where you need to have some legacy analog blackburst to time some, let's say, some legacy devices. So for that, we have a great solution. This is called the 7800 SRG. This is a PTP to blackburst converter. It's a little modular card, fits in our 7800 frame. The idea being, if you were running, a full SMPTE ST2059 infrastructure in your facility, but way in the back of your facility, you had some legacy equipment that needed some color blackburst. Rather than having to run, a couple of thousand feet of coax with distribution amplifiers to bring, one piece or a couple of blackburst outputs to that area, you could use something like the 7800 SRG. Just plug this into your PTP network, and you'll have 6 independently timable black outputs that you can use. So this gives you a lot of additional flexibility in both IP 2059 as well as sort of hybrid facilities where you might need that little island of analog black. So next thing I want to talk about is some of our RF solutions. And at NAB this year, we're going to be launching another brand new product. I think there's a press release on this actually in that press kit link I sent you. This is called the XRF4. Kind of internally, we call this the Bumblebee router, just kind of the way it looks. This is the industry's most compact RF router. So in a 4-rack unit frame, right, it has a 64 by 128 RF matrix in it. It has a lot of the features and functionality of its bigger brother, the XPRF large router. Has an embedded spectrum analyzer, the ability to take both RF and fiber signals in the back. So it's a very, very small, very, very flexible routing platform. We also have, new this year, the XPRF XL router. This is the same chassis as the XPRF router, but it has twice the capacity. So rather than 128 by 128, it's a 128 by 256 switch matrix. Again, in the same chassis as the existing XPRF. We also have a new 7880 IRD series. These are our integrated receive decode solution. Big new development with this. Again, for this transition to IP, it now does support SMPTE ST2110. So next thing I want to talk about is our live media and production solution. So this is primarily our Dreamcatcher live media and production platform. Lots of new things that we're going to be showing at NAB this year for our Dreamcatcher platform. First thing, 8K support. So, we are in this age right now of UHD, but there also is a lot of interest right now in 8K, a lot of applications for 8K. Primarily for things that we're seeing for 8K now in terms of applications are things like pan and zoom with crop out. So, we have applications where you might have an 8K camera shooting an entire playing field. And from there, using Dreamcatcher, we can cut out a little HD raster and essentially create almost like a camera within a camera for tracking movement within that raster. Also, another new product we're going to be showing at NAB this year, the Dreamcatcher 1. This is our cost-effective sort of entry-level Dreamcatcher platform. This has that same core Dreamcatcher feature set. Up to 8 channels. It has a fixed amount of storage. But this can also be fully, nice thing about this, it's a very low cost of entry into the Dreamcatcher platform. But at some point in the future, if your requirements change, it also has the ability to be upgraded to our full Dreamcatcher 400 series of a Dreamcatcher, our Dreamcatcher platform 400 series. It can be fully upgraded to that. Also, for a slightly different application, primarily sort of a news application, we have a new product called the Dreamcatcher 200NZ. And essentially what this is, it's a platform that has 12 low bit rate encodes for XDCAM, either 35 or 50 megabit. Some of the core features that it has is continuous loop recording. So you can use this for continuously recording, let's say, incoming news feeds. And because, like all Dreamcatcher platforms, you have immediate access to all of the content, on the Dreamcatcher platform, and you can export it to offline editors, such as like an Avid platform, if you want to do some sort of external editing. A concept, a new architecture that we're going to be demonstrating and talking about at NAB is something that we call the One Facility. So if you think about a typical media organization today, a lot of the infrastructure tends to be sort of very siloed. So you might have a live production infrastructure, in one facility. You may have like a news infrastructure in another facility, and you may have another production infrastructure in another facility. These tend to be sort of very siloed with no real thought given to how to most efficiently leverage these resources when they're not being used. Basically, you can't readily share resources between all of these different silos. So with the one facility concept, we call this our distributed production architecture. And essentially what we're doing is, through the power of IP, we can actually access all of these different resources across your entire facility and make better use of them. So essentially, we can, if we were to create, actually go to the next slide here. There we go. So let's say we had a particular production event that we wanted to do. We needed a bunch of different cameras, we needed a bunch of different replay systems, multi-viewers, sort of resources spread across your entire facility. Typically in the past, you wouldn't have been able to leverage all of those different resources. But with one facility, you can access and reach all of these different resources, through your integrated IP network. And then through the power of Magnum, our orchestration platform, you can actually control all of these different resources and schedule them so that they are actually available when you need them. So in a lot of cases, the operator who's going to be working on this particular live production, he may not even know where some of these resources are located because they're no longer sort of co-located or clustered in either the venue or your primary facility. They can be anywhere in your organization. You know, with Magnum and its ability to control and schedule resources and the IP network, you know, all of these resources are now immediately available sort of everywhere in your organization. And then, you know, once this particular event is done, you know, one of the big advantages of this, you can do something that we call like a one-touch configuration. So, you know, pressing, you know, with a few mouse clicks, you can essentially reconfigure this entire architecture, you know, for your next event. So rather than having to run around, physically change cables and move resources around physically, this can simply be done all now, you know, over IP with just a few mouse clicks, you know, through your Magnum sort of orchestration and control infrastructure. So it's a very, very powerful new architecture for doing things. One of the big changes, or one of the big trends I mentioned that we're seeing is a high dynamic range, or HDR and UHD applications. So, you know, we've been, since the earliest requirements for UHD, you know, Evertz has been providing UHD solutions. So we offer solutions for UHD in 4-wire, 12 gig, as well as IP. Now, as an example of this, you know, you take a look at our EQX router. This is our workhorse router. Now, this has been around for, I think, 10 or 11 years now. And, you know, it started out as a 3 gig SDI router, but as the industry requirements have changed, you know, we've kept updating and providing solutions, you know, to address these new requirements. So you can also do, you know, 12 gig to quad 3, from quad 3 to 12 gig type of interfacing. We offer IP-based gateways in 10 gig. You know, we're also going to be showing one in 25 gig at NAB. And the reason that we do this is that, you know, our users tell us, our customers tell us that, you know, routers are obviously capital expenditures. They tend to be the heart of your facility, and they want to get as much use and as much life out of these things as they can, because, you know, they're big, they're difficult to replace, and you don't want to do it too often. So again, we have been developing sort of these IP sort of gateway and hybrid solutions to help them extend the life of these type of baseband routing platforms, so that they can kind of do this controlled and orderly transition to IP when it's convenient for them to do so. So other solutions that we have for our EQX router is a new product that we're going to be showing at NAB this year. And this is essentially a 12 gig. Then we apply a little bit of mezzanine level compression so that as it goes through the router, it only goes through 3 gig, and it comes back out 12 gig on the other side. Typically, if you want to do 12 gig in an EQX router today, the way essentially you have to do it, you got to go 12 gig in, and then we convert that to quad 3, and then it comes back out 12 gig. So, you know, the limitation with this approach is that you're using 4 3 gig links through your router. But with this new gateway card, we can go in 12 gig SDI, we apply a little bit of compression, and then we go through the router, 3 gig, and we come out 12, decompress it again, come out 12 gig on the other side. So we're essentially saving 3 gig links that we previously would have had to use. So it just preserves some of that bandwidth within your router. Also, we have some 12 gig SDI UHD up-down cross conversion solutions, like our 7814 UDX provides up-down cross conversion for in 12 gig. Also has the ability to do high dynamic range conversion. Also new, we're going to be showing the EMR 128 by 128. This is our large 12 gig SDI router. We also are going to be showing a new cost-effective routing platform called the EMR. Available in a couple of different sizes, 32 by 32, 64 by 64. This initially comes provisioned as a 3 gig router, and then through some software keys, you can actually you can enable 12 gig routing within it. Also, we do have some new UHD IP multi-viewers, a 3067 VIP 10G. One of the demonstrations that we're going to be showing at NAB this year is the 3067 VIP's support for SMPTE ST2110. Now, the next thing I want to show you, this last section here, is some of our Evertz AV solutions. So essentially what our Evertz AV solutions do is it lets someone, let's say who has an Evertz SDVN network or facility, it lets them extend the functionality of that network beyond sort of that core broadcast function. So within your organization, you know, you may have the requirement to share content sort of outside of that primary broadcast application. You may want to push content to some of your corporate boardrooms or even the corporate lunchroom, all sorts of places within your organization. So Evertz AV, gives you the ability to sort of extend the functionality of your SDVN network into these sort of other sort of non-traditional areas, and gives you the ability to share content, what we say, everywhere from the first floor to the 50th floor of your facility. So the Evertz AV solutions, they do use the same EXE switches that's used in broadcast facilities, uses the same Magnum orchestration and control system. And what it does is it has a series of different standalone in-room sort of media hubs. So you can take one of these hubs, you can put it into your corporate boardroom, and you can get out all the different types of outputs that you might need to drive projectors, or drive different types of screens within that boardroom. Also gives you the ability to have keyboard video and mouse sharing. So the Evertz AV platform is a very, very powerful way to sort of extend the functionality of that traditional SDVN sort of core broadcast infrastructure. So again, just in closing, please take the time to come see the Evertz booth. Go check out the IP showcase, and really so you can just kind of see that, as I mentioned at the very beginning, that I really do think that this year is sort of the year that IP has really come of age. So just in closing, I do have some more of those these press kit cards. So if anyone wants access to any of our our press releases, if you haven't seen them, you can just come get this card, and there's a link on it.